Hello and welcome to Citrix Converge 2020. I'm Mayur Vadhar from Citrix App Delivery and Security team, and I'm going to walk you through on how can you get your apps, your innovation to production faster. We'll see how infrastructure as a code approach to ADC can empower you to do that. We'll also see some of the open source tools like Terraform and Ansible and how they can be used to automate your ADC configurations and integrate as part of your existing infrastructure. Great. So you can see that we have pretty exciting agenda for you. We'll start by understanding the HMC adoption trend. We'll look at some of the top challenges and the use cases that organizations have, that organizations who are part of adopting HMC. Then we'll give a brief overview of our HMC portfolio, and then we'll see our ADC automation framework. Post that, we are going to deep dive into each of the automation tools that we have, from Nitro APIs to Ansible, the Terraform, public cloud templates, and then our own Citrix ADM. We have two demos planned for you. One is the Terraform to deploy ADC in AWS, and the other one on how can you integrate ADC with CICD through ADM style books. Great, then let's get started. Organizations across globe have realized that to keep up pace with the innovation and drive agility, they have to adopt hybrid multi-cloud strategy. Hence, we see most of the organizations have some sort of hybrid multi-cloud strategy in place. And especially in today's time with COVID-19, organizations have realized the importance of cloud to facilitate seamless work from home experience, to cater to high user traffic, and also ensure business continuity. Right, and that's why we see that increased spending in cloud is anticipated going forward. But this multi-cloud journey brings its own technical challenges. In such distributed environment, today development team, IT admins, so networking team have to work on varied technologies that require multiple skill sets, understanding of different underlying cloud infrastructure, or even varied application architecture, such as microservice-based architecture. The team is faced with different tools and interfaces and mechanisms to control and monitor these deployments that are distributed across environments. And as your app stretches across environment, the exposure to security threat increases big time, and staying compliance becomes tougher and tougher. This brings us to some of the popular use cases that needs our immediate attention as we adopt multi-cloud strategy cautiously. We need automated provisioning capabilities to create self-service infrastructure across your HMC environment. Automation is key to driving agility and adoption of different technologies. Not only teams are looking to automate this, but they also want to integrate more and more infrastructure into their existing CI/CD pipelines, right? Such as security policies to accelerate application delivery. Centralized management of your infrastructures bring strong control and governance, and this is very much important to adopting hybrid multi-cloud. To meet your fluctuating demands, autoscale is the need of an hour. And also to smoothen out your infrastructure migration from on-prem to public cloud, right, is a key important use case to make sure that we are not compromising on any user experience and business is always running. Keeping all this in mind, we have very well-rounded product offerings in our HMC portfolio. We have ensured that Citrix ADC is available to customers in variety of form factors and on variety of platforms which may be appropriate for your needs. We have software-based form factor called virtual appliances. We call it as VPX that can be used on-prem data center or private cloud setup or even in public clouds. In public clouds, we call them especially the VPX. They are made cloud aware to understand and operate in underlying cloud infrastructure. Then we have a variant of it called CPX that is used to support microservice-based architecture in a cloud-native environment, having Kubernetes. Moving forward, the BLX product is also a relatively new offering. This is version of ADC that is available on bare metal Linux platform, right? So we don't have a hypervisor layer, and because of this uh, reduced one layer, you can expect a high performance. Apart from that, we have hardware form factors also available called MPX. A lot of customers have deployed this on their data center, and this gives a very high performance. Along with that, we have a multi-tenant version of MPX called SDX. So main principle behind this is to customers have a different environment, they have different deployment needs, and based on those requirements, they can choose the form factor that best meet their needs. Biggest advantage we have is that all this is based on single software code base. So naturally with that, you get same capabilities across this, and transitioning from one form factor to other is very, very easy. Now, to drive ease of use and accelerate your HMC deployments, we provide you a comprehensive automation framework to the HMC use cases that we discussed. In an HMC environment where your ADCs can be of different form factor and that are deployed across environments, Citrix ADM acts as a control plane to your entire fleet of ADC infrastructure. Citrix ADM comes with lots of automation, security, and advanced analytic capabilities. In this session, we are going to look further of some of the automation capabilities that Citrix ADM brings. Along with this, we provide you integration to other automation tools that you might be already using, such as Ansible and Terraform. Ansible and Terraform, being infrastructure agnostic tools, can help you to deploy or configure your ADCs across different environments. We also provide you with public cloud templates such as AWS CFDs, ARM templates, GDM templates to provision your ADCs in public cloud. And lastly, we also have a Nitro APIs which can be used for any custom automation. Now, we are going to deep dive further on each of these tools along with a couple of demos that we have. Our entire automation framework relies upon Nitro APIs, and then you can configure your ADC by calling Nitro APIs. Nitro APIs are synchronous in nature. This means that the client application waits for a response from the Nitro Web Service before executing another Nitro API. Nitro API are particularly useful if you want to write your custom automation framework. To facilitate the same, we provide Nitro API SDK in Python, Java, and .NET. The Nitro package is available as a tar file on the downloads page of the configuration utility of the Citrix ADC appliance. Now let's look at our ADC automation through Ansible. Ansible is an open source tool for automating the deployment and configuration of IT infrastructure. We provide Ansible modules for Citrix ADC, and these are available for any user in GitHub to download it and use it for free. As you see here, we have different components as part of the Ansible modules. The modules itself, which are written in Python. Then we have an inventory, which is a text file. And along with that, we also have playbooks that are defined in YAML. All these Ansible components primarily leverage our Nitro APIs to call to ADC and configure different use cases such as load balancing and WAF, and many others. Now let's go to GitHub to understand these ADC modules better. So as you can see that I am in a Citrix ADC Ansible module repository that we have hosted in GitHub under Citrix org. Right, so any user can come here, check out these modules and download it for their use. As we see, we have different folders over here, and we have very solid documentation which you can go through to understand how to go about installing Ansible, how to set up Citrix ADC Ansible modules so you can start configuring your ADCs easily. So let's check out some of the important files over here. Going to the Ansible modules folder, these are basically Python modules that is written by our team. All these modules that are available here cater to different use cases of ADC, such as load balancing, content switching, application firewall policies, GSLB, right? So each of these modules might be calling one or more Nitro APIs to communicate to ADC and configure the use case. And we keep on adding more use cases, more modules in this Ansible module folder, so users can use it, this automation framework, for more and more use cases. Along with that, in the samples folder, we have different YAML files. In Ansible terminology, these are called playbooks. And this playbooks helps you to define the desired state in your ADCs. So let's look at a particular playbook and we'll get a better understanding. So let's have a look at the service group.yaml file. As we can see here, this file is kind of easy to understand if we understand how Ansible works. So the first line, that host with variable as Citrix _ ADC, basically it's telling that go and configure the below configurations on this target host. So my Citrix _ ADC is a host name, and the credentials for it I have stored it in another file. You can see that we have a list of tasks here, set server 1, set server 2, set service group, and then we have monitor bindings. Basically, we are setting up a sequence of tasks that would make Ansible know, okay, what operations I do need to do. So it is going to create a server, and these are the variables, different variables that is going to configure for us, right? It is going to create 2 servers, and then it will create a service group, and it will bind these 2 servers to a particular service group. So as you see, this particular playbooks call different modules. You can see it is calling Citrix ADC server module. Then we have another Citrix ADC service group modules. So basically, this are all the modules that we saw in our Python Ansible modules folder that we have written in Python. Right, so as we see over here we define our desired state of the ADC, and this is the inventory file where we define the credentials and the endpoints of our target ADCs that we want to configure. And this is a sample command that we will be running to configure our ADC. It's very simple, Ansible -playbook, and you tell us, okay, look at this inventory file where I have the target ADC configurations, and use a particular playbook YAML file that defines the desired state of my ADC. So let's look at how these commands would look like. Here we can see I have 2 screens. This is my remote host, and this is the target ADC node, right? And over here you can see I have inventory file open over here where I'm saying, okay, here is my target ADC with this IP, with this username and user password. And in the right side, that's where I have logged in over here, and you can see we don't have any server, we don't have any service group here. Now here is the sample playbook that we just saw in our GitHub. I have downloaded it in my remote host, and we can see that I have put the actual configurations that I want as part of my ADCs. Right, and I'm going to run this Ansible command as we see here, Ansible -playbook samples inventory pointed to the inventory file and the playbook file that I'm going to run. And it shows me that it was able to create or configure this successfully. As we see, 3 resources were changed, and we get an OK signal here. Right, and now on the right hand side we can see, okay, what exactly initially didn't had any server, it didn't had any service group, but now post the playbook configuration run, we can see that 2 servers were created and 1 service group was created, and it is actually bounded to these 2 servers, right? So this configuration was applied on an end device. That's the beauty of Ansible. You can just define the desired state of your ADCs in a simple human readable YAML file that we just saw, and it will take care of configuring it for you. Similarly, we have Terraform modules for Citrix ADC. Terraform is an infrastructure management tool developed by HashiCorp. It is known for its infrastructure as code approach and the declarative approach towards automation. To use Terraform, You need to install Terraform first in your local machine and then copy the Terraform Citrix ADC binary to appropriate location. Using Terraform, not only you can configure your ADCs, but you can also deploy your ADCs in public cloud, which we are going to show you shortly. In a typical Terraform setup, you will see there are different files. Provider.tf, it contains the target ADC details. Resources.tf contain the actual resources, the entities that you want to create in your target ADC. Variable.tf contains the different variable types. And tfvar contains the actual configuration values that you want to use for your target node. Using Terraform is very easy. There are three commands that you need to be familiar with: Terraform init, Terraform apply, and Terraform destroy. We'll see all this in action in our upcoming demo. So for our demo, we are going to show you how Terraform can be used to deploy ADC in an edge configuration in an AWS environment. Post ADC deployment will show you how you can configure your ADCs to load balance the traffic to the different backend servers which you might be having. So as you see here, we have two ADCs which are configured in an HA mode. All these are deployed in a single AWS VPC. And we have backend servers where we will be routing the traffic to. So now let's jump on to the demo. In this video, we'll take you through the detailed steps involved in provisioning Citrix ADC. So this is our GitHub repository for Terraform modules. The scripts can be broadly categorized into two types of Citrix ADC deployments, such as standalone and high availability. And we have high availability in same zone and across zone, as you see here. Let's understand our GitHub scripts better. The networking.tf defines the parameters for configuring the AWS infrastructure. Provider.tf lists the cloud provider with different credentials required to register your provider. Here our cloud provider is AWS. And Citrix ADC.tf contains the Citrix ADC configurations such as network interface, IAM policies, instance type. So in the first section, we are going to deploy Citrix ADC HA pair across availability zone in AWS. So copy the latest file from GitHub Terraform Cloud Scripts, and let's do some preparation before executing the script. Let's fetch and store them in a file ending with auto.tfvars. As the Terraform scripts only read the input variables from this file name. Now we need to declare each of these variables, but some of them have default values, as you see here. And if you want to stick to defaults, comment them or else assign them appropriate values. For AMI mapping, refer to our Citrix ADC AWS CloudFormation GitHub repository and get the appropriate value as per your subscription and region. I have selected BYOL and CA Central 1 location. For the instance type, fill the offerings available in AWS Marketplace region. Fill in the relevant details as shown here. The controlling subnet is the set of IPs you want to grant access to the VPN instance. Here I have allowed only my machine IP. Also, you can assign unique AWS SSH public keys, which will be stored in your Linux system that will help you to SSH into your ADC instance. Likewise, fill in the details for AWS region, access key, secret key, availability zones as stated here. Also, please ensure that you have enough elastic IPs in your AWS region for the deployment to go through. With Terraform init, you can initialize the necessary cloud providers and their configurations. With Terraform apply, you can instantiate the Citrix ADC deployment and its underlying ADC infrastructure. So we'll have to click yes here. And now we are going to validate all the resources that are created. The output section contains different resource IP, security group, VIP, SNIP, NSIP, all these details, which will be served as input parameters when we configure our backend servers. So here we can see that our ADC HA pair is up and running. And we can log into primary instance of HA pair with the NSAPI using admin credentials. Here we can see that our LB server is created, which is currently in down state. This is because that there are no backend servers configured. So our next section is about how we can deploy Ubuntu backend servers with Apache installed. Now for your use case, you might already have your backend servers running. So I'm going to show the next section of deploying the backend server very quickly. So now to configure your Ubuntu backend servers, you can go back to GitHub, and we have a folder here in AWS, and we go to simple LB across LB zone. So these are different files and the code that we have that you can use in a similar fashion to create two Ubuntu backend servers with Apache installed. Right. As I said, you might already have the servers, backend servers running in your environment. So now the process is same as we have seen for provisioning our ADCs. We are going to initialize it using Terraform init. Then we are going to instantiate the resources using Terraform apply. So here the output section, we can see that our backend servers were created successfully. We can see the management IPs and the service IPs for that thing. Okay, we can see in AWS that we have now two other instances, Terraform Service Node 0 and Terraform Service Node 1 running. Basically, these are my two backend servers. And not only that, these two backend servers are now configured with our Citrix ADC pair. So any traffic that is being routed to any of these backend servers will get load balanced across this Node 0 or Node 1. So we'll see that. So here when I log into my ADC, I can see that my load balancing vServer is up and running, as we see here, because basically it is accepting the traffic and it is routing the traffic to the two backend servers that we just deployed. Let's verify if the backend services are actually load balanced by Citrix ADC. So using client IP, let's access our backend service, and we can see that they are load balanced in a round robin fashion. Once we are done with the setup, you can terminate all the Citrix ADC using Terraform destroy. Yes, with one command, you can destroy the entire setup that Terraform had created. Make sure that we don't have any resources there in AWS for which we are incurring charges. With this, we come to the end of the demo. Hope this demo helped you to understand how Terraform can be used in an easy way to deploy ADCs and to configure use cases such as load balancing. We provide ADC templates for various configurations, such as standalone, high availability for your public cloud deployments. Using templates within very few clicks and providing values to very few variables, you can set up your cloud infrastructure and deploy VPX. It helps you to deploy VPX in recommended topology, removes any manual errors, and reduces setup time as well. This VPX can be of BYOL or even a marketplace offering. These templates are readily available in Marketplace, and at the same time, we have certain custom and advanced templates that we provide in GitHub. These GitHub templates can be used as is or can be further customized to suit your requirements. This brings us to our last section where we showcase how our own Citrix ADM can act as an automation control point to your entire HMC infrastructure. ADM provides a host of capabilities as we see here. We are not going to go into details of each of these as this is covered in a separate session that also has demos for the different features that we see here. So some of these capabilities are around provisioning, configuring applications, upgrades, and integrations. Under provisioning, we provide you with a smart deployment feature using which you can just give basic parameter values and it can set up required cloud infrastructure and deploy VPX for you in AWS or Azure. Similarly, you can configure your autoscale in your ADC to cater to fluctuating traffic. ADM also provides you capabilities to provision VPX on SDX. To configure your ADC, we provide declarative style books with which you can configure different use cases in ADCs. For regular maintenance of ADCs, we provide config jobs where you can run commands across your fleet of ADCs in few minutes. ADM also provides you with intelligent upgrade features that allows you to conduct smooth upgrades of your ADCs. It also has SSL certificate management capabilities and configuration audits to meet your compliance needs. We also have third-party integrations to ServiceNow, Slack that can be used to create issues or notify certain events. As you see, we have comprehensive automation capabilities to cater to different needs of yours. Now let's deep dive a little bit into stylebooks. Citrix ADM stylebooks take an infrastructure as code approach to ADC. You can define your desired ADC configuration in YAML templates, and stylebooks will figure it out on how to configure your ADC. We have pre-built stylebooks available in ADM, and also we have some standard business application stylebooks which can be used to deploy. Also, stylebooks can help you to migrate or replicate ADC configurations from on-prem to cloud. In this way, you can ensure your consistency across your Citrix ADCs in your distributed infrastructure. Stylebooks offers you multiple benefits, such as auto-generated UI, where you just need to fill certain variables or the targeted configurations of your ADC. It is very much customizable and can be reused to configure different ADCs on different environment. It also has role-based access control to give access to your stylebooks to different teams as per your needs. In our upcoming demo, we are going to show how can you automate and integrate ADC configuration with your existing CICD pipeline. Here is a quick illustration of the use case where application developer wants to update and increase his web app backend servers from 2 to 3 to cater to high traffic. We'll see how Jenkins, GitHub, and ADM can be integrated so that ADC can be configured as part of CI/CD pipeline seamlessly. Now let's see this in action. So as you see here, I'm currently logged into my ADM service where you can see that I have an existing load balancer and it's routing traffic to 2 web app instances, and our objective is to update it to 3 web app instances. Here is the GitHub repository for my ADM stylebooks. Inside this, we have config packs created from stylebook templates. Update config pack.py is a Python script used to log into Citrix Cloud Service, establish session with ADM, and trigger ADM stylebook through REST APIs. The config pack JSON file contains my new ADC configuration settings that will be used as payload to the REST API. Here we are going to update the ADC settings to route traffic to 3 web app servers. And we are going to commit this change. Here is the web app repo where I have all the source code for the application. And just for this demo, we are going to make small change and commit it. And this commit is going to trigger a Jenkins pipeline. Coming to Jenkins setup, here I have 2 pipelines. My web app pipeline is to build, deploy, and test the web app. As we make changes to the web app, we'll see soon this pipeline getting auto-triggered. As we see here, and this pipeline is going to trigger my another ADM stylebooks pipeline. You can see my ADM stylebooks pipeline running. Let me show you how I would configure the ADM pipeline. As you see that it pulls stylebooks and config pack from the GitHub. and it calls this Python script that I mentioned earlier. This Python script is basically used to log into my ADM and call ADM stylebook KPIs. In the console output, we can see that ADC configurations were successful. Coming back to my ADM service and refreshing it, we can see that load balancing service is updated to route traffic to 3 web app instances as we intended. This brings to the end of our demo. So try out the ADC and CICD integration yourself and empower your teams. Here are the various resources that we discussed in our session and used for our demo. You can explore our automation framework and use one or multiple tools that suits your needs. So this brings to the end of our session. Here are the major takeaways from this session. Citrix ADC provides extensive automation options to suit the different needs of different customers. Automation is key to adopting your HMC journey as it abstracts away the complexity associated with your underlying infrastructure, be it ADC form factor or different kind of architectures as well. It also helps you to eliminate the ADC configuration errors and brings repeatability to your setups, and also helps in reducing setup time. Great. So I hope that this session was exciting for you. I hope that you learned some new tools or new ways of automation that we provide. And I hope you will make use of it to take your apps to production faster. Thank you. Thank you for watching.